Alright guys, so this would be some short notes. This is all about adding polynomials. We've looked at it in the last couple days, and now we're going to start doing some operations with them. So that's what our goal is. We're going to add polynomials. Tomorrow we're going to subtract. We're going to eventually multiply and divide them as well. What's really nice about today, though, is we're really going to be doing a lot of what we did yesterday. And yesterday we just combined like terms. So when adding polynomials, all we're really doing is we're combining some like terms. The problems are going to look like this one down here. Here's an old state test question, an old Regents question that you might see, where it has two polynomials and there's a plus sign in between it. Notice the plus sign. Any idea what the parentheses are doing in this problem? So what's super nice is really all that the parentheses are doing is they are separating the two polynomials. A lot of people think that there's some distribution going on here, so even though there are parentheses, we are not distributing at all. We only distribute, I'm just going to put DIS, when there's something right outside the parentheses, like a 5 or something like that right there. Notice how there's only a plus sign right outside, so you're not going to distribute here. So really, all that this is it's a problem just like yesterday. The parentheses really aren't even necessary. Like, I could get rid of them, just like that. But what's even nicer about today than yesterday is that all of these problems are really going to be in standard form for you already. And that's what I start to say down here when I start to do one of these. So they're like the problems from yesterday, but more organized. So you should know where your biggest degrees are going to be right away. They're going to be in the front of either the one on the left or the one on the right. So just like yesterday, I want us to draw some lines down to separate all my different terms. And then all you really need to do is combine some like terms. And just like yesterday, I started off trying to find the biggest ones. And you know that the biggest one is either going to be over here or over here because of the whole standard form thing. So which one of those is bigger, x to the third or x squared? Obviously x to the third. So let's put the 5x to the third right there. After that, you can sort of scribble it out if you want to. Now what? Obviously some x squareds. So how many x squareds do I have? I have a 7 right here and a -1 right there. I have 6x squareds. Notice how I did not do 6x to the fourth. Some people that are a little bit confused on this mix up like that. So let's get rid of those. And now I just need to look for my x's. If I have -10 and +6, I have -4 x's. And last but not least, the -4 and the -1 make -5. And that's it. If you wanted to, you could check to make sure that it's in standard form by drawing the lines down again and seeing what the degrees of each one of these is. 3, 2, 1, and 0. And what is the degree of that polynomial? It's 3. And how many terms does it have? It has 4. Nice. All right, and that's it. So really our answer was just this right here. All good? Pretty easy? Let's do one more together, and then I just have 2 examples for you, and then we're done. So again, this one's pretty big. So I would draw the lines down to separate all my terms. Look at a crap ton of terms. And now let's start finding my biggest degrees. I think the biggest one I see here is an x to the fourth, so I'm going to put this -x to the fourth right there. Scribble it out because there's a lot here. And then I'm going to look for some x to the thirds. I see this -4 and that +2. When I put those together, I get -2x to the thirds because the negatives win. How about x squareds? If I have a -2 and a +4, who wins? The positives or negatives? Obviously the positives win. 2x squared. Then I get a -x and a +5x. That's going to be a +4x. And last but not least, I have a -3 and a -2. That is -5. There's a lot there, but that is really just one answer. That's our one big polynomial. Doesn't have a special name because it's so large. All right. So on the next page, I have 2 for you guys to try. I'll pause the video, try them, and unpause it to check and make sure that you did it correctly. All right. So let's take a look. I'm going to draw these lines down to separate. I'm going to find my biggest, which just happens to be y to the, or y squared on both. So how many y squareds are there? Negative 7 y squareds. How many just regular y's are there? I'm going to go positive 4 y's. And then if I have 1 and a negative 2, I end up having negative 1. And that's it. So it's a trinomial of degree 2. All right. And number 2 might have been a little bit more tricky because it had x's and y's in it, but that's okay. We can do that. So let's draw our arrows down again, or draw our lines down again. What is my biggest out of all those, no matter if it's an x or a y? It's to the 4th. So I end up having this y to the 4th. How many y to the 4ths are there? I think that's the only one. So I have 4 y to the 4ths. All right, so now what has to go next? Really, it doesn't matter. So you could have had 2 different answers here. You could have put the negative 2y to the 3rd next, or the negative x to the 3rd next. Usually math people put x's before y's because of alphabetical order. So I'm going to do that. Negative x to the 3rd, and then negative 2y to the 3rd. But it really didn't matter if you had those 2 switched. Now, how about some x squareds? I see 6 over here and 1 over there. So that's a 7x squared. And then I have a negative 5, and that's it. So I'm just going to put negative 5x. And then 3 and 4 gives me 7. Okay? And that is it for today's notes. I have some final thoughts here for you guys. When you add polynomials, all you're doing is combining like terms. The polynomials in these problems are all in standard form, which is awesome for us because then we can find which one has the biggest degree right away. The parentheses are there to just separate the 2 polynomials. And remember, like terms need to have the same letter and the same exponent. What I mean by that is 3x squared does not go with 5x. They are not like terms. All right, guys, so that is it. Thanks for watching. And yeah, that's it.